Assalamu alaikum dear students. In this video we will see exercise 5.3 fourth sum and seventh sum. If you want to see our previous videos on differential calculus, you just click that I button at the top. Now we'll get into the sum. So exercise 5.3 fourth sum, xy plus y square equal to xy plus y square equal to tan x plus y, right? So we have to find dy by dx. So let me take this to be my equation 1. The formula that I am going to use here is, I am going to use derivative of x power n is n into x power n minus 1. I am going to use this formula. Then derivative of tan x is secant square x. Then I am going to use the uv formula. uv whole dash equal to vu dash plus uv dash. Now I am going to use these three formulas here. Now let me differentiate equation 1 with respect to x. So let me start with this term. I want to differentiate this particular equation. I will start from my first term on the left hand side. Now it is x into y. So x into y. So let me take this to be my u and this to be my v. This to be u and this to be v. Now if I want to differentiate this, so obviously it is two variables are there. It is in product. So obviously we have to use uv formula, right? So v u dash. So v u dash means put v as it is, that is y as it is. Derivative of u. The u dash is nothing but v u dash means we put v as it is, that is y as it is. U dash derivative of x is nothing but what? 1 plus uv dash. Now put x as it is. Derivative of y is what? 1, but we have to put d by d. I have differentiated y with respect to x. I didn't write that here. You just write it, right? So one term over. I have differentiated this particular term. Now coming to this term plus. Now derivative of y square according to this formula is what? 2 into y power 2 minus 1, which is nothing but 1, right? So 2 into y, we should put d by d. I have differentiated y with respect to x equal to right hand side. Coming to this term, derivative of tan x is nothing but secant square x. Derivative of tan x is nothing but secant square x plus derivative of y is nothing but 1. I have to put d by d. I have differentiated y with respect to x. Now some of you might get a doubt that why we are putting dy by dx here, dy by dx here, dy by dx here, and for these two terms I am not writing it. Why? What is the reason? Because here I am differentiating, I am putting y as it is and differentiating x. So what I must put, if you see our previous videos, you will be clear with it. We will put dx by dx and it will get cancelled, right? So it's the same thing here, secant square x, then I have to, tan x derivative is secant square x, then I have to differentiate that x. Now I'll get 1 there, then I'll put the dx by dx. So where we are differentiating y, there we will be having this dy by dx. If you see our previous videos, you will know that. Now let me make it simple. Y plus, no need to write this one, x into dy by dx plus 2y into dy by dx equal to secant square x plus dy by dx, right? Now what I can do, I want dy by dx, so let me take all the dy by dx term to one side. So let me take this dy by dx to this side. So what I'll be getting, and this term does not have dy by dx, so take this term to this side. So what I'll be getting, I'll be getting x into dy by dx, x into dy by dx plus 2y into dy by dx. If I take this dy by dx this side, it will become minus dy by dx equal to right hand side I'll be having secant square x minus, if this y this goes this side, it will become my plus y will become minus y. Now I want dy by dx, right? So what I can do, I can take dy by dx common from this. If I take dy by dx common from this, what I'll be getting? I'll be getting x plus 2y minus 1. X plus 2y minus 1 equal to, what is my right hand side? Secant square x minus y. My right hand side is secant square x minus y. But I want dy by dx, so let me take this term this side. I want dy by dx, right? So dy by dx equal to secant square x minus y by x plus 2y minus 1. So this will be my dy by dx. Hope you got it. Now we'll get into the exercise 5.3 7th sum. So exercise 5.3 7th sum is seventh sum, sine square y plus cos of xy. Sine square y plus cos of xy equal to k. Now this k is some constant, right? Now let me take this to be my equation 1. Now if I differentiate, what are the formulas I am going to use here? I am going to use derivative of x power n. The formula is n into x power n minus 1. Derivative of sin x is cos x. Derivative of cos x is minus sin x. And I'm going to use uv formula over here. Uv the whole dash equal to vu dash plus uv dash. Right. Now I'm going to, as usual, I'm going to differentiate this equation 1 with respect to x. I'm not writing it. Right. So I'll start from the first term. This is the first term on my LHS. Now sin square y is nothing but, I have told you, sin square y is nothing but sin y the whole square. So take this entire term to be x. Derivative of x square is what? What is the derivative of x square? Derivative of x square will be 2x. Y square will be 2y. Right. Something. So that theta square will be 2 into theta. So sin y the whole square will be what? According to this logic, sin y the whole square derivative will be 2 into sin y. 2 into sin y. So derivative of sin square y is 2 into sin y. 2 into sin y. Now I have to differentiate that x. This entire term I have taken it to be like x or y. Now I have to differentiate that x or y. So sin y derivative is what? Cos y. Yes. Then I have to differentiate that y. Derivative of y will be 1. So I must put dd. I differentiated y with respect to x. So this term over. Coming to this term, cos of xy. Cos of xy. So coming to this term, cos of xy. Cos x derivative is minus sin x. Cos y minus sin y. So cos of anything minus sin of whatever is there, we will write it. Then we will differentiate what is present there. So I have xy there. Now I have to differentiate that xy. So if I differentiate that xy now, it is in product. X is also variable, y is also variable, and they are in product. So if two variables are in product, definitely we have to use uv formula. No confusion in that, right? So xy, if I use uv formula, put y as it is, derivative of x is 1. Yes, plus vu dash over plus uv dash. Put x as it is, u as it is, right? This uv. So v dash, derivative of y is nothing but 1 d by d y x, right? Equal to, right hand side it is a constant which is alone, so equal to 0. Got it? So I can write 2 sin y cos y is nothing but what? What is the formula for 2 sin theta cos theta in trigonometry? Sin 2 theta. So I can write it as sin 2y into dy by dx. Plus of minus will become minus of sin xy, minus of sin xy. Or let me take this inside, minus y into, I can write it as minus sin xy into y, minus y sin of xy, minus y into sin of xy. If I multiply with this, I will be getting minus x into sin of xy into dy by dx equal to 0. Now I want dy by dx, right? So I'll take the dy by dx, these two terms as dy by dx. This term does not have dy by dx. So let me take this term to this side. So what I'll be getting? I'll be getting sin 2y into dy by dx, right? Minus x into sin of xy dy by dx equal to what? This term I'll take to that side, will become y into sin of xy, right? Now I must take what common? Dy by dx common here. So if I take dy by dx common, what will be left out? Sin 2y minus x sin xy. Sin 2y minus x sin xy will be left out. Equal to right hand side, what will be there? Y into sine of xy, y into sine of xy. Right, now I want dy by dx, so let me take this term to the side. So what I'll be having? I'll be having dy by dx equal to what? Y sine of xy divided by sine 2y minus x into sine of xy. So that's it. This will be my dy by dx. Y sine xy by sine 2y minus x into sine of xy. So this is it for this video. In the upcoming videos, we'll see some more exercise sums. Right. So if you like this video, please click the like button, share with your friends, and subscribe. And don't forget to get our regular notification. Don't forget to turn on that bell button. Thank you.